Okay, so two things. One, we should be about ready to start on these. Two,
How are we doing the other one first?
yeah, did you bring yours in today?
No.
Then we will not work on it until there, it's gonna be impossible to work on it until
Yeah.
there. So you're working on those bushings, keep working on those. If you would make me, one of these today, it's just 1.5 inch diameter, 1.25 inch long, it's a little bit out of scale. 3/8 to 3/80 hole in it, you can just drill a 3/8, it just needs to be able to, a 3/8 bolt needs to be able to go through it, okay? Face it, part it, if you need to face the back side, then face it as well, it needs to be smooth on both sides. Okay? So, what's that? No, that's steel, gotta be well done. All right, so really the next project in line for you is your, the modify your tap guide. Do you have your tap guide? Way to go, thank you for being responsible.
I have like 7 of my parts in my
Yeah, that's it.
It's like everything that isn't like the hammer, the punches.
Right.
I
did
like,
everything home
most of my
since last
CNC stuff
semester.
was my dad
Okay.
and my
yeah.
welding project too.
Okay, all right.
I took everything home last semester and got it
Yeah.
back in.
Get it back in, that way we can be using it for things, because whenever I say, hey, grab your punches and let's do this, you'll have your punches there to do that. So I don't know how much good it's doing you at home. Doorstop or something like that. So
It's a pretty good paperweight.
totally good paperweight, yeah. I've used a lot of them for stuff like that over time. Okay, so get those in, we'll talk about that again. All we need to do is work on the V on the back side of that. So then your next project, your next new project in line would be the vice stop. There's 2 parts to it. They look very much the same, but they are not quite the same thing. Tell me the differences between the 2.
Ooh, one has a .25 and one has a .26 through hole.
Yeah,
One got the taps and the other don't.
right. One has tapped holes in it, or a tapped hole in it. One has reamed holes in it, and just the other one has then through holes to it. And so I can show you what a finished one of these looks like out in the shop. I've got a couple of them. And so it's 1/2 by 1/2 square stock, and you're going to make it 1.43 long. So maybe if you saw them 1.5 inches long, you can then you got about 170 to take off of it, take some off both sides. If you didn't saw this in half, then you can go ahead and mill this step in it, that ledge, and then cut them in half and then mill the ends of it off. I think it's just as easy to have 2 pieces. You can put both pieces in the vise at the same time, mill that step across both of them, the shelf. It needs to be 250 deep. And then you'll see, but it's not symmetrical. So it's 250 this way, but it's only going to be 125 the other way. See, it's not 250 by 250 step, it's 250 by 125 step. Yeah. On this one, these holes are 260 through, so F drill would be 257. That'll take you intolerance for that. And then these holes, same thing, 260 through, F drill. 5/16 would be a 312. We'll give you the counter bore on that. It'll give, if you use a drill for it, so it's going to give you a little bit of a drill tip on the end, a little bit of taper, it won't go all the way down to the tip because you've just got a really small step. That's the spring pocket. Okay, so this one has basically that same spring pocket on it, 250 deep, so there's a lot of similarities. This one has a tapped hole. So when you put these 2 together, you end up with 2 dowel pins that go in here. Then you get a tapped hole here. You got the spring in here, so you put the spring in the pocket. You got the 2 dowel pins sticking out. You put the one piece over the other piece. You take your socket and cap screw it down. It expands and contracts, and the spring loaded to open back up.
Yeah, I saw the one that you showed us last time.
Oh, okay. Yeah. So those are, all of our normal stuff.
There were 2 of them.
What's that?
It has a spring in the big hole in the seat.
Yeah, in the middle, yeah, and then the bolt goes through it. What's that?
Those are two different parts, right?
They are two different parts.
That's what I mean.
A lot of it is the same stuff.
Just one's got
The
the.
length is the same, the shelf is the same,
holes
the,
same diameter.
well, the counterbore hole is the same thing.
Yeah, most of the stuff is the same, just some of the
Except for
holes
the-
are the same.
Exactly.
The holes different.
These are drilled and reamed, so you'll want to drill them 240, ream them out to 250, and then we're going to press pins into that, and then we will we'll tap this hole here. So tapping you've done before, reaming you've done before, drilling you've obviously done before, and then we'll just be milling this step on there. You've done milling, and just make sure that you're conventional cutting as you're going. When this gets done, it will be one assembly. I only need your name or identification on it, just somewhere on the assembly of it, not on the pieces of it. I'll give you then all the pieces that go to it. I got springs, suck-in catch screws, and dowel pins, and then that way you can have those things already. Questions? How long do you think this should take you?
It depends when you want that.
Today?
That.
Okay.
Then I need to put my holes in.
About 2 days.
Well, no, I don't necessarily, I'm not asking you what day of the week you're gonna be done. How many hours do you think this should take? That's what I'm asking you, sorry.
If I start
In
right
realistic
now.
time?
Yeah, like, by the time you start to finish on this part,
By
like,
the time I walk into that shop right there and start
Right.
working
It
on
should take
that,
about 4 hours,
Yeah,
it's probably
so
gonna
let's-
take 2 days.
Yeah.
I think I could do that in 3 hours.
3
I
hours,
was saying 3-4 hours,
3-4 hours,
That doesn't seem super complex.
right?
but it's not gonna happen.
So, but realistically, so I was
Maybe 2 hours,
talking,
probably.
I was talking to a group yesterday on flow cell, and one of the things that I had explained to them was, when I ask you how long it's gonna take you, I'm looking for a realistic time of how long do you think it's actually gonna take you.
2 classes.
What I don't want you to say is what you think I want you to say, and then I also don't want you to buffer it so badly that you look awesome because you blew the time out. So here's my example. I use this example a lot. When I first started the shop, I was running the saw, and one of the owners came to me, and so I ran the saw. I was a delivery driver. One of the owners came to me in the middle of this big saw job and said, "When are you gonna be done?" And I said, you know, I just went to absolute best case scenario. I was like, I could actually probably be done tonight. And so, the minute I get back, I go and do a couple of deliveries, come back, somebody else is sawing, goes back and forth, all these other things. It takes me 3 days to get the saw job done. I really only still had about 4 or 5 hours in the job. But what happened was there were all these other things that I couldn't factor in. One, because I just didn't understand how things worked. I was 20, and I was just trying to figure out what was going on. He was my boss. I was trying to tell him what he wanted to hear. And so he came back to me later on, and he goes, "When I ask you when you're going to be done with the job, I need to know when you're going to be done with the job to the best of your ability." He says, "Because what I did was I scheduled saw jobs to run after that to go do machines that were going to be bar fed. And so it took you 2 days longer. So those 2 machines, they sat waiting for you to get done. Had you told me, this is how many hours of sawing I have to do, but I have a lot of other jobs to run, it could take 2 days, I would have ran other parts on those machines and then ran the bar jobs later on." He's like, "But now you essentially cost me 2 days of spindle time on those 2 machines at $60 an hour times 2 spindles times 2 shifts equals a lot of dollars." And he's like, "I can't have you do that to me." He's like, "Because yes, I was super impressed that you said you could be done by that day, but then I was just super mad the next morning when I came in. And then I was more mad the next morning when I came in and it wasn't done because it was then 2 days into it." And so he had actually, he read through what I was doing and could see that I wasn't gonna do it and had already switched the jobs around. But I screwed his whole schedule up by me not just going, I know it's gonna take me 4 hours to do this sawing, depending on how much driving you have for me to do. And so what I would do from that point on is I would be on the saw and he'd be like, "I need you to run to Gardner Denver." I'd be like, "Okay, that's gonna be 3 hours off of this time. Either get somebody else over here on the saw or just Just know that. And he'd be like, yep, totally, that's all I needed to know. I'll plan on that being 3 hours later. Or I'll go grab somebody and have them come over here. Then he made those decisions from that point on. That way the saw was always running. All the cogs, you know, were turning the way that they should, so.
Realistically, it should take us 4 hours, but it should take me 2 class periods.
It should take you an hour and a half to do
I'm
that.
telling you exactly what's gonna happen.
Yeah.
I'm telling you what's gonna happen though.
Okay, so let's lock you down to 4 hours to get this done. That's just over a class period.
That is not today.
And it's fine if it's not today, but I want you to be thinking about when you're working on this. I want to circle back to you and say, how much time did you actually have in that? Like the bushing. The bushing was going great until it
2
wasn't.
hours, yeah.
Well, it's 4 hours now,
Yeah, 4 hours, well.
because you're starting all over again.
Putting a lot deeper that low.
Is it
Yeah.
a through hole, by the way?
It is a through hole. All this is, okay, so we're clear on that?
Yeah.
Okay, all this is a bushing. They're gonna weld a handle to this. It pivots on basically a 3/8 bolt. It's just the body of a lever, and it just needs to rotate this way.
Oh, okay.
The only thing that you need to know is that the steel that you use for it needs to be low carbon. You already have metrology?
Yeah.
You know, you use PMI gun?
Yeah.
Okay, make sure that you're using something with low carbon content, okay? So low chrome, low carbon. You've got a piece of material you've already been working on. That would be a good piece for him to pull from to use. 'Cause
Oh, yeah, next is one out there.
yeah, it's 1018, so it'll work.
An
But
inch and a quarter long?
1.25 inch long, yeah. And really, this and this, I mean, if you're within a 30-second, totally fine.
Me, if it was within 1,000, not good.
Right, so Eric made a bushing this morning. The bushing OD was supposed to be 1.499. He made it 1.497. And it is unacceptable at that size. So, and I feel like he thought he was still probably within a good range.
It was a bit slide on, but it's not that.
Yeah, it's supposed to be a press fit, and he was like, look, I think that's probably gonna be okay.
Looks like that.
Nope.
You know, fun fact, you can put a knurl on there to increase your
Yeah,
diameter if you need to press fit stuff.
So I thought about that to try to save the part.
I can cut a lot deeper now, you told me I could cut deeper, so it should be done in less than an hour.
The problem with knurling, this is gonna go into the sleeve, this is the sleeve for the adjustable pulley on the mill head.
Once the knurls get beat down, it's gonna be done anyway.
Yeah, knurling holds something in, but it doesn't really, like, it does compress the knurl as it goes in. So you're only getting about 50% engagement because of the raised up areas of the knurl. So it's not the best situation at all.
But it's better than it not fitting at all.
Right, in an emergency situation, yeah, it will work. And if I were to knurl it, I wouldn't use our diamond knurl, I would use a straight knurl. And it puts like lines all the way across it, so it's easier to push into it. It is a valid fix for a lot of things. It's not gonna be for this because it spins so fast. Like, a lot of times they do it on valve guides and stuff like that for engines, you know, things that slip through something else, and those are totally acceptable places for it. This one, if it were spinning at 100 RPM, probably be fine with it. This thing spins at about 2,000, and I just, safety's sake, I'm not okay with it. It just seems like it's gonna be problematic. Okay,
I thought about it, but I was like, no.
yeah, it's just,
Compressed.
yeah,
the way it needs to
it
be.
needs to be size to size, or, you know, about a 5/10, maybe 5/10 clearance, but it needs to push together. We'll Loctite it together, and then we'll weld the ends of it, and then we'll also run a bolt down through it,
Are
just
we
to keep
welding
it. No, we'll take it over welding, let them take the ends of it, so.
Cause I'm in TIG.
Are you?
Yeah.
So the only difference,
Certified.
the only, what's that?
I'm certified in Arctic TIG knots, is that what?
So the only tricky part of this is it's cast iron steel. So they are dissimilar metals,
Yeah.
but it'll work. I mean, it's fine. So, all right. If no questions about that, then you guys are free to go. Get started. I will post this on YouTube and